Hello, in this video we are going to study about the application of strain gauge and types of strain gauge. Now, the application of strain gauge. The strain gauges are extensively used in the field of geotechnical monitoring to keep a constant check on structures like dams, tunnels, and buildings, etc. Now, the first application is in aeroplane. Aeroplane's wings need to be strong in order to fly correctly. Testing the amount of strain a material can take allows to engineers to find the strongest material in the plane. So, it is necessary to uh, gauge the strain of aeroplane's wing. At that time, we use the uh, strain gauge for measurement. That is, strain gauges are fixed on the structural components to measure the stresses along the load path for wings, deflection, or deformation in the aeroplane. Now coming to the bridge. Bridge maintenance companies use strain gauge to know the bridge become weak so that they can become fixed before the bridge breaks. To ensure the condition of bridge, we use strain gauge. These sensors are used for sensing the bridge condition. If it is any abnormal, somebody can fix it and accidents can be avoided. These sensors tells us the bridge is weak so that we can fix the bridge before the bridges break. The instrumentation of bridge is done to verify the design parameters, that is, evaluate the performance of new technologies used to construction the bridge, to verify, control, and conception of process, and for subsequent performance of the well-instrumented bridges can alert the responsible authorities about the approaching failure so as to initiate the preventive measures. Choosing proper sensor types, technology, a measurement range, and their location on the bridge is very important to optimize the cost and extract the full benefits of instrumentation. It becomes necessary to monitor the bridge regularly for any kind of deformations, as it might lead to a fatal accident. Strain gauge technology is used to real-time monitoring of huge bridges, making the inspection precise. For example, Yamuna Bridge in Allahabad, Naini, is a 630-meter cable-stayed bridge across the river of Yamuna. The bridge is installed with many measurement channels that sense wind speed, and strain on its cable. Now the important one is rail monitoring. Strain gauges have long history to safety of rails. It is used to measure stresses and strains on rail. Strain gauge measure the axial tension and compression with no impact on rails. In case of emergency, the strain gauge can generate a warning, so maintenance can be done early to minimize the impact on rail traffic. Now coming to the classification of strain gauges. Main classifications are wire gauge and semiconductor gauge. In the case of wire gauge, they are divided into unbonded, foil type, bonded, etc. Now coming to unbonded strain gauge. An unbonded strain gauge has resisting wires stretched between two frames. A rigid pin of two frames are insulated. When the wire is stretched due to an applied force, these forces can relative motion between two frames and thus a strain is produced, causing the change in resistance value. This change of resistance value will equal to the strain input. That is, here in the case of unbonded strain gauge, there are two plates. First one is always fixed and second one is movable one. A wire is connected on the pins of the fixed and movable plate. If the strain is occur, the movable plate will move and the strain is occur on the wire, and this force will be equal to the strain on the force. Now coming to the bonded strain gauge, this can be connected to a paper or a thick plastic film for support. The measuring leads are solderable or welded in a gauge wire. The bonded strain gauge with a paper backing is connected to elastic membrane whose strain is to be measured. That is, in the case of bond gauge, bond wire type, this type of structure, that is a comb-like structure, is our wires are formed, and the direction of strain is either this type, and here a paper tissue and a fine wires are there, and if any compressions or force is applied, at that time the strain is occur on the wire, and that can be converted into voltage. In the case of foil, the wire is replaced by a foil type comb-like structure. That is, bonded metal foil strain. These are the examples. Similar to the metal wire strain gauge, only foil is used in place of thin metallic wires. They are manufactured by photo etching process. They can be take different shapes rather than comb-like structure of the metal foil. The advantages are, they have all advantages of bonded metal wire. In addition to reduce the transfer sensitivities, they are much cheaper due to ease in manufacturing. Now coming to the semiconductor strain gauge. The semiconductor strain gauge has high piezoresistive properties. That means it has a gauge factor of very high gauge factor. The advantages are, they are most expensive, very cheap, strong output signal, and no creep, and high pressure range. And the disadvantages are the temperature. They are temperature sensitive. That is, semiconductor is a high sensitivity to small variation in temperature, and output is always a non-linear output. And another type of one is rosette strain gauge. These are the strain gauge. They are designed to multi-directional. Since unidirectional strain gauges can only measure the strain in the direction of its alignment, it does not provide the detailed data. There are two or more bonded structures are present in rosette strain gauge, and these are the main classifications of strain gauges, that is bonded, unbonded, foil types, semiconductor, etc. Thank you.